Hey, what's going on, folks? It's Mike here, and welcome to the Deep Programming Language series. In today's lesson, I'm going to give you a real gem, something that's really useful in the deep programming language in my experience, and that is something known as universal function call syntax. So let me go ahead and dive in, and I'll try to show you how this can improve the understandability of how you write and read programs in the deep programming language. So with that said, what we're going to actually do is go to the Learn section here from the deep programming webpage, and dgems, the first one here is universal function call syntax. Now, again, as noted, this is a key feature in the deep programming language, and it can make your code easier to write. And I'll basically go with this example here, and then we'll write a few of our own to understand how this works. So just looking at this example here, you can see that we read this function call from inside out. So bar is operating on A, whatever that data type is, and then the function foo is called. But rather than reading inside out, most of us, or those of us who read left to right, might be more familiar or more comfortable with this sort of syntax that shows us the order of the operations that things work, rather than working from inside to outside, which isn't as natural of a reading order, especially for those of us used to reading left to right. So what we're really doing is taking the data A, this first argument here, and then calling this function and then calling a successive function here. So in the deep programming language, this allows us to chain functions together. And if we've got a function that only has one argument, like this one in particular, we can actually just lead with that argument if we want. So you may find that clear, you might not, but the important part is that you can just chain these functions together, and that makes things really useful. Now, also in the deep programming language, you don't have to use parentheses for functions, for instance, that don't have any arguments. And if we look quickly at the D style guide here to one of the style things, we want to use that carefully. So if I go ahead and just search for example, parentheses, they've got a little note here on the property syntax. We probably still want to call our write function with the parentheses. I like doing that just to make things clear, but you can do this if you want. Again, the useful thing is really this example here showing the chaining. But again, if we want to come over to some program like this and do data write line, we can do that. Again, maybe if you're writing some really quick script, that's a nice thing to do. Again, adapt to your style guide and preferences. The point is that you can do it, but it's nice, or that's a feature that we get with universal function call syntax. So that's it for universal function call syntax. Let me go ahead and show you an example, and again, try to motivate you why this is a nice thing in the deep programming language. So I'm going to use some of the standard algorithms, and while we haven't talked about these in depth in the Phobos library, so again, going to documentation, library, and then getting to the standard.algorithm page, I just want to go ahead and show a few that will be useful and show you how we can improve our code. So here's our example here, again, of doing data.writeLine, or again, I probably prefer data and then passing in the argument in most cases. But as far as the chaining goes, let's go ahead and work with some example here. Like, let's just go ahead and grab some of the values from data. And the way that I'm going to do this is by sort of processing the actual data here and maybe filtering out the data or sorting it. Okay, so we have a few things that we can use from algorithm, and we might want to convert that data to an array and perform some operations. So just follow with me. The important thing is the universal function call syntax. And what I'm going to do here is filter that data. Now, this is a template here, and it requires a predicate. We'll talk about templates, we'll talk about predicates, lambda functions, and these things in the series, so make sure you subscribe later. But the point is, I just want to filter out everything that's greater than, say, 0 here, or maybe greater than or equal to. So only positive integers. That'll get rid of this value -1 here in our output. Okay, so let's just go ahead and start with that and build this up here. In this example here, I have a undefined identifier here. Let me make sure I add the arrow here. There we are. So that's our predicate. So basically what this is saying is, for each of the values coming in here, treat the argument A, and then compare. If it's greater than 0, we keep it. So that's what you can see here in this particular new dynamic array here, or array-like range. Now, the next thing that I want to do here, so I can operate on it, is to just call dot array, and then I'm going to sort this data here. Okay, so you can try something just like this and running it, and now you'll see, look, we have an array of data sorted here. And again, as I always like to do in this series, let's look at the type of our values, just so again, you can see explicitly, I have a sorted range that is returned. Okay, and that's why sometimes you'll see the dot array take place here. In fact, we can try to, let's try to rearrange these here. Let's see if I can filter and sort. Well, here I need to provide a little bit more with my sort here. Okay, so I might want to do something of this nature here, but I need to pass in some way to sort it. Okay, some rule here. Let's see if that gets us a little bit further. No, it looks like we need to actually be operating on an array here. So let me go ahead and change that back. But you kind of get the idea here. This is nice to read left from right here. I've got a data. I'm going to filter it and take things that are greater than or equal to 0 here. I'll do, then I'll convert this to an array, and then I'll sort that array. And then I can, let's go ahead and, convert it back to an array. And we can see now we have an int array here, okay, if that's what we want to work with. So this is quite nice, and sometimes you'll see this if you're coming from a language like JavaScript, for instance, where folks will do their chaining, or C# or other languages, and you can sort of see step by step what's going on here. Okay, so here's my actual array that I get back. Now, once we learn about sorting and filtering and some of these other things here, we can change the rule here. Maybe I want to do A less than B here. Okay, and that's the one way that we can sort our keys. And then maybe I want to reread this and do, no, I actually want B, well, actually, the argument's names doesn't really matter here, but I want to do A greater than B. So basically, if I rerun this, you can see that we've now reversed the order that this takes place. So I'd argue again that this is still easy to read. Again, we know how we're filtering our array. We know how we're sorting it based off of this rule, and that's not too bad. So let's go ahead and try to do the same thing without universal function call syntax. So what I'm going to go ahead and do here is just create a without UFCS. So let's be without universal function call syntax. And this was our example with UFCS, and see which one you like better. So then I have to kind of do, okay, we're going to do filter, and we're filtering by, okay, so anything greater than or equal to 0, and our data is our argument. So again, I'm going to slowly build this up just like I did last time, right? Programmatically, that's what we might want to do. And again, we can write out values 2 just to see what we're getting here. And we get to our values 2, so it is filtering. And now I want an array. So I've got to wrap this in an array here. And that's still working, that's good. Now I want to sort it. Okay, so just like we did last time. And I can sort it. Okay, now it is sorting. And then I want it back in the array form. Okay, because maybe I want to pass this into some other function that doesn't take a sorted range or do some other operations. And I run it, and okay, it's looking pretty good. And well, now again, I want to change the order. So again, this is a template here. So A greater than B. And let's go ahead and squeeze this into one line as best as we can. Oops, looks like I made a mistake here. Let me go ahead and, oops, I was modifying the sort function, of course. See, I've already gotten lost here. And hopefully you're kind of seeing my point here, because I want to make a refactoring, and I got to figure out with my IDE here exactly what I'm doing. A greater than B, just like we did here. Well, now let's get rid of this exclamation. And whew, okay, made it here. And I wasn't trying to mess that up. I was messing that up as I was typing, as I like to do kind of live here. But that's the kind of point, which one do you like reading? This one or this one? Now, if you've coded this yourself, maybe you can understand this, but imagine reading someone else's code and trying to figure out what exactly is going on here. Now you might have some strategies, for instance, to kind of break this up, in a language like that doesn't support universal function call syntax. You could probably, break this up into some, way that makes sense here with the functions. I don't know with the spacing. It's kind of becoming a disaster. But you get the point that it's kind of difficult to refactor and figure out what's going on. I have to look at these parentheses. I have to see what the templates are. Again, in D, we can get rid of some of these parentheses here, for example, to make things easier, so we don't always need them there. But again, just take my word for it or try yourself and see what you like. Again, a lot of these things come to preferences, but again, this is much, much easier to read. I really enjoy universal function call syntax. And at the end of the day, what the compiler is doing is it's lowering this form to this actual code. So it's just a purely, syntactic thing. It's doing the same thing. It's just that we can read this, in my opinion, much better by spacing it out here. And that's going to make things less prone for errors. And if you need to update and refactor this code later, it's much, much easier to do so. All right, folks. So with that said, feel free to check out this lesson as well as all the other lessons here on my website, courses.msha.io. You can track your progress here, learn about all the different ways that we've been using functions, for instance, and make sure that you don't miss a lesson. So make sure you check that out. And thanks for your time, folks. I hope you enjoyed that. I hope you now understand universal function call syntax. It sounds like this really fancy thing, but it's just an awesome thing that helps you write your programs in a more readable way. Again, as a programmer, you're going to spend a lot more time probably reading code, and especially reading code that's not yours. So again, I like that this is a part of the language. I like using it myself. All right, folks, give that a subscribe if it was useful. Give it a big thumbs up. And otherwise, I'll look forward to seeing you in the next lesson.